Assalamualaikum. Today for the first question, title and clear figure of structural items as introduction. So our topic is rudder. For extra info, a rudder is a flat vertical surface usually made of metal or wood used to steer a boat by deflecting water flow. It's typically located at the stern of the boat and pivots on a vertical axis to change direction. The rudder works by creating unequal water pressure on either side when turned, cause the boat to turn in the direction of lower pressure. So this is the example of rudder, and yeah, thank you.
Okay, the definition of rudder. Rudder shape appendage that is hinged or privately mounted or at near distance of a watercraft or anti-vertical stabilizer of an aircraft. Its primary defining characteristic it is capacity to generate a controlled lateral force by altering its angular orientation relative to the flow of the surrounding fluid, whether water or air. This generates force act upon the vertical center of gravity, producing a turning moment about its vertical axis, thereby enabling directional control and maneuvering. In essence, the rudder serves as a pivotal element in governing the yaw motion of a vessel or aircraft.
For features of rudder has blade. This is the flat or foil-shaped part that is submerged in the water. It turns to redirect the flow of water, causing the ship to turn. Second one is rudder stop. This is the vertical shaft that the rudder blade is attached to. It extends upward, connecting the steering gear. For the last one, steering gear connecting. This is the mechanism that allows the person steering the ship to control the rudder. It can be the tiller, a lever, or the steering wheel connected to the rudder stop via mechanical or hydraulic system.
Assalamualaikum. My name is Aina Sabrina binti Muhammad Nazri. So today I would like to present about riders. So this is the different types of riders. We have four riders here. First, we have balance riders, which is this balance riders are designed so that the center of pressure is located along the rider stalk, reducing the steering effort required. This configuration enhances maneuverability and minimizes the load on the steering gear. Balanced riders are particularly advantageous for larger vessels where efficient steering is crucial. Next, we have unbalanced riders. Unbalanced riders have the entire rider area off of the stalk. While this design requires more steering effort, it can provide greater stability, especially in smaller vessels. Unbalanced riders are often found on older ships and smaller boats where simplicity and robustness are prioritized over efficiency. Next, we have semi-balanced riders. Semi-balanced riders have a portion of rider area ahead of the stalk, providing a compromise between balanced and unbalanced designs. This type of rider offers improved controls at various speed and is commonly used in medium-sized vessels. The semi-balanced configuration provides a balance between maneuverability and stability. And lastly, we have flap rudder. A flap rudder is an advanced type of ship rudder so that features a hinge flap on the trailing edge of the main rudder blade. This flap moves in coordination with the main rudder and improve the vessel's steering performance. They are especially effective for slow speed maneuvers such as navigating through narrow channels. Thank you.
Okay, I will explain about function, purpose and application for rudder. Okay, for function, to steer and maneuver the vessel by redirecting the flow of water past the hull. When the rudder is stirred, it creates a pressure difference on either side, generating a lateral force that turns the ship. Okay, for purpose, allow that ship to change its heading and navigate a desired course, enable the ship to make turns, dock, undock, and navigate in confined waters. It also helps maintain a steady course against disturbance like wind and currents. Okay, for application, in ensuring the ship follow the intended routes, assisting in berthing, unberthing, and maneuvering within harbors, providing the necessary control in restrict channel and river, maintaining course and making necessary adjustment due to weather or traffic.
How the rudder work? Okay, the rudder works by changing the direction of water flow past the hull when you turn the steering wheel or tiller. It's connected to the rudder, causing it to pivot to one side or the other. As the boat moves through the water, this angled rudder blade distributes the otherwise smooth flow. Okay, the side of rudder that's angled into the flow create higher pressure, while the opposite side experience lower pressure. Okay, this difference in pressure generate a force that pushes the stern of the boat sideways in the opposite direction of the rudder angle because the stern is pushed sideways. Okay, the bow pivots in the other direction, causing the boat to turn. Okay, the greater the angle of the rudder and the faster the boat is moving, the more pronounced this pressure difference and the resulting turning force will be. Essentially, the rudder acts like deflector, using the power of the water flowing past the hull to steer the boat.
And then for the next question, explain the constructions of the structural item with figures and proper labeling of their important parts/components. So there's this picture that I found in Google, and there's a complete labeling to it. And then for the important parts/components, first is rudder stock, a solid or hollow shaft that transmits the steering torque from the steering gear to the rudder blade. The top end connects to the steering mechanism. And then for the second one, we have rudder blade, a thick steel plate cut to the desired hydrodynamic shape. The leading edge is typically rounded, and the trailing edge is often beveled for efficient water flow. And then next one is spintless. Cylindrical pins or shafts attached to the rudder blade or a supporting structure welded to it. This acts as a pivot points. And then for the next one is bottom end plate, a welded plate at the bottom of the rudder blade, providing structural closure and sometimes additional reinforcement. And the last one is steering gear connection, the point where the steering mechanism connects to the rudder stock. And then the next one we have the construction process. First is design and material prep. Detailed plans are created and high strength steel is selected and cut to shape for the rudder blade and internal components. The rudder stock is also prepared. And then the next one we have rudder blade construction. And then we have solid plate. A thick steel plate is shaped, edges are prepared, and pintle supports and a bottom plate are attached. And then we have fabricated. Internal stiffeners are assembled and welded. These plates are welded to form the outer shape and a palm plate. And pintle bosses are attached. A bottom plate is also welded on. And then we have the rudder stock and pintle attachment. The rudder stock is machined and then securely connected to the rudder plate. And then for the next one of construction process, we have gudgeon fabrication. Corresponding sockets for the pintles are made and precisely welded to the ship's stern structure. And then we have assembly and checks. The rudder is trial fitted into the gudgeons to check alignment and movement. Bearings and seals may be installed. Final welding and securing of components are completed. And then we have the last one, surface treatment. The entire rudder assembly and gudgeons are coated with anti-corrosive paint for protection.
In summary, the rudder is crucial control surface for ship and aircraft, enabling directional control by manipulating fluid flow. Angling the rudder generates a lateral force causing yaw. Rudder design vary based on the vehicle and its needs, from simple boat rudder to sophisticated aircraft configuration. Regardless of design, the rudder effectiveness is vital for safe navigation and maneuvering. Future advancements promise even more efficient and integrated rudder system, and is highlighting its enduring importance for controlled movement in water and air. That's all from us. Thank you.